Grafana Alloy is one of the newest tools of Grafana, and here in this course, I'm going to show you how to work with it to collect different types of data, such as logs, metrics, traces, and so on. Hello everyone, my name is Mohammed and welcome to CodeOps by Mo, my YouTube channel. In this course, we'll get familiar with Grafana Alloy as a collector, okay? This course has 3 different sections, collecting logs, metrics, and traces. In the first video and in the first section, we will dive deeper into collecting logs. As you know, we have different types and forms of logs. The logs of local files, the logs of systemd journals, the logs of Docker containers, and Kubernetes pods. Okay? We're going to collect all these logs with Grafana Alloy and send them to Loki. But before that, we need to install Alloy on our server. You're able to install Alloy on different platforms, such as Linux, macOS, Windows, Docker, and Kubernetes. But for this course, I'm gonna install Alloy on Linux. And in Kubernetes section, you will learn how to integrate Alloy with Kubernetes as well. So don't worry about it. So let's go to install Alloy on our Linux server. Okay, to install Grafana Alloy on your Linux server, first of all, you need to go to Alloy documentation and then click on Setup and Install. And you will find different platforms here, but for now, I choose Linux. I scroll down. First of all, you need to define the environment and the operating system you're using. And based on that, you need to follow its instructions here. Okay, my operating system and my environment is Ubuntu, so I need to follow the instructions here. Actually, I installed Alloy already, so I don't need to install it once again. But if Alloy is not exist for you, you need to follow the instructions based on the environment and operating system you're using. To verify our installation, I go to my terminal and I type systemctl status Alloy. As you can see here, Alloy is not up and running yet, but its service is now available on my Linux machine. To start and enable Alloy, you need to scroll down and click on Run Alloy here. First of all, you need to start its service and enable it here using these commands. So first of all, I copy this command to start Alloy service. And then I need to enable it. Very good. So I type systemctl status Alloy once again, and you can see here that Alloy is now up and running without any problem. And okay, so you need to follow these steps as I did here. One of the most important things I want you to remember is the config path of Grafana Alloy. When I go to my terminal and I type systemctl status Alloy, you can see that the default config path of Alloy is this, etc alloy config.alloy. It means that you need to put your configurations into this single file. Okay, it's okay, but I think there is a limitation here. In some cases, you want to have multiple Alloy configuration files instead of a single file. For example, you want to have a specific config file for collecting logs of your Docker containers, a specific file for collecting logs of local files, or your systemd journals, and so on, okay? You want to have multiple configuration files instead of a single file. So you need to override the default config path of Grafana Alloy in this situation. So to do that, you can go to etc default alloy, and here you can change the value of config file. For example, instead of a single file, I want to use a directory, for example, opt alloy. And I want to put our Alloy configurations into this directory, and this directory will contain our Alloy configurations, okay? And I need to create this directory. So I save the file, and before restarting our Alloy service, I need to create that directory. So I type sudo make dir opt alloy. Very good. And this directory is now available on my Linux machine. So we need to create our first Alloy configuration file. And after that, we can restart our Alloy service, okay? Okay, the first example and the first scenario here is that I'm going to discover local files on my local file system and read their log entries and send their logs to Grafana Loki. Because of that, I created a file called local.alloy. Please pay attention that the name of your config file must end with .alloy. It's important. In this file, we have different components, but the first one is local.filematch. This component actually is responsible to discover files on your local file system through path underline targets parameter. Using this parameter, you can specify the path you want to discover. For example, here, I'm going to discover a single file called var.log. Okay, but you're not limited to just actually discover a single file. You can also discover multiple files at the same time using regex. For example, I can change log to ***. Will match any subfolders of var directory, and also I can change auth to **log. Okay, so regex helps you to discover multiple files at the same time. But if you prefer to discover a single file, you can change it to something like this. Okay, local.filematch also syncs the local file system with the targets you specify every 10 seconds. Let's imagine that you are using regex to discover multiple files, okay? But after 2 hours, you decide to, for example, add a new file or remove a file, okay? So syncs helps you to detect these new events, these new changes, okay? You can change the sync period using sync period parameter here. The default is 10 seconds. Very good. So overall, we can actually discover files on our local file system using local.filematch component. The second component here is loki.source.file. This component actually is responsible to read the log entries of the targets you specify. Okay, you can specify the targets like this. Targets equals to a list of multiple paths. For example, the first one is tmp_foo.txt bar and baz.txt. It means that you want to read the log entries of these targets. But in this example, I'm going to specify the targets based on the files discovered by local.filematch. So instead of this syntax and instead of this for, I type targets equals to local.file_match.local. The name here is local. This name actually is not important. It can be everything, okay? For example, if I change it to test, I need to change it here as well, okay? And the last one is targets. Please pay attention that the name of the exported field of a local.filematch component is targets. So you need to type it here. It's required, okay? Because you want to use the exported field of this component. Therefore, you type targets here. Okay? Very good. Another parameter here is tail from end. You can change it to true if you want. And we have a block here that I commented out. Its name is decompression. Let's imagine that your targets are compressed files and you need to decompress those files. Because of that, you can specify a block called decompression and use its parameters here. But in this example, my targets are not compressed files. Therefore, I commented out decompression block here. Okay? Another parameter is forward to. You can forward the log entries to any other Loki components. For example, here, I'm forwarding those log entries to Loki.write component. Loki.write, the name here is local, and here the field name is receiver. It's important. Receiver is required, but you can change local if you want. If you change it to test, you need to change it here as well. Okay? It's important. Loki.write is the last component I'm using in this file. It has an endpoint and a URL here. This is the URL of your Loki instance. Okay? Loki API v1 push is required, but you can change the URL of your Loki instance based on the environment you're using. Very good. So now I'm going to copy this file. Let's go back to our terminal. I go to OPT Alloy. If you remember, I overrided the default config path of Grafana Alloy and I changed the default config path to OPT Alloy. This is actually a directory will contain multiple Alloy configurations. Okay. So the first one will be, for example, local.alloy, and I paste that file here. Very good. So I need to be sudoer, so I type sudo vim local.alloy, and I paste it here as well. So now I need to restart Alloy service. So I type sudo systemctl restart Alloy. And I type status instead of restart. And very good. As you can see here, right now, Alloy service is actually up and running. So now to see the log entries of the file we discovered, we need to go to Grafana. I already installed Grafana on my Linux machine. You can do that as well. And first of all, I go to data sources section here. I already connected Grafana with Grafana Loki. To verify it, I click on save and test, and it returns a message that data source successfully connected. Very good. So to see the log entries of the file we discovered, I go to Explore section. First of all, specify the data source. Our data source is Loki. And the label. I click on Select Label. The first one is file name. I click on it. And the value is var log off.log. If you remember, in our Alloy configuration, we discovered a single file called var log off.log, and we have this file here as well. It means that we successfully discovered this file using Grafana Alloy. So I click on it, and I click on Run Query. And as you can see here, these are all log lines and log entries related to actually var auth log off.log, actually. Very good. So the first scenario was about discovering local files on our local file system, reads their log entries and sends the log entries to Grafana Loki. So very good. So now let's dive deeper into the actually second example in the second scenario here. The second example, we are going to read the log entries of systemd journal and sends them to Grafana Loki. Okay. Therefore, I created a file called journal.alloy, and we have different alloy components here. The first component is Loki.relabel. This component is responsible to rewrite the label set of each log entry. In this example, we are talking about the log entries of systemd journal. Therefore, I need to rewrite the labels and the fields of systemd journal. Okay? The prefix of the labels related to systemd journal is something like this. Underline, journal, underline, field name. This is actually a prefix for internal fields and labels for systemd journal. And here the field name is underline systemd unit here. Okay, and we are going to replace this source label with a target label like unit. Your target label can be everything you want. Okay, for example, here the name of the target label is unit. You can change it if you want. Okay, there is no problem. So please pay attention that we have a role block here, and this block has two important parameters. The first parameter is source underline labels. The labels we're going to replace, for example, this is a list actually, okay? The first item of the list is underline journal, underline systemd unit, and we're going to replace it with unit as a target label. Okay? But please remember that you are not limited to just use a single rule block. You can use, for example, one or more than rule block in your Loki.RuleLabel component. Okay? So there is no limitation to use any number of blocks, rule blocks actually. Okay? Very good. So in the first component, we actually replaced this source label with this target label. Once again, I want to say that the target label can be everything you want. Okay? This name is not important. It depends on you. The second component here is Loki, the source, the journal. This component is actually responsible to read the log entries of systemd journal. Okay? It has two important parameters, forward to and relabeled rules. Forward to actually forwards the log entries of systemd journal to any other Loki component, and here the another Loki component is Loki.write. Okay, so it actually forwards the log entries of systemd journal to this component here. Okay, and one of the most important parameters of Loki.source, the journal, is relabeled rules. If you remember from the previous component, we applied actually one relabeling rule, and we are going to use that rule within this component. Okay. Therefore, I type relabel rules as a parameter, and its value is the exported field of Loki.relabel component. This component has an exported field, and the name of that field is rules. Okay? Therefore, I type Loki.relabel. The name here is journal, therefore I type journal here as well. And the name of the exported field is .rules. So I type rules here. Therefore, Loki.source, the journal, actually uses the rules of the first component here before forwarding them to Grafana Loki. Okay? It's important. And another actually component here is Loki.write. We're going to write the log entries of systemd journal to our Loki instance. Therefore, this is the URL of our Loki instance. Very good. So I copy the content of this file, and then let's go back to our terminal. I go to OpenTelemetry, where we hold our Alloy configurations here, because if you remember, we overrided the default config path of Grafana Alloy. So here I create a file called, for example, journal.alloy. And I type it here, and so I need to be sudo. Very good. And I restart Alloy. Very good. So let's get a status of Alloy, and everything is good. So let's go back to our Grafana instance. I go to Explore section here, and the default data source is Loki, and I'm happy with it. And I click on Select Label. We have two new labels actually here, service name and unit. Okay? If I click on service name, and if I click on select value, its value is Loki that stores the journal. This is actually the component that we configured earlier, okay? And the second one is unit. If you remember from the rule that we actually configured here, we replaced a source label with a target label called unit. Therefore, the name of the field and the name of the label here is unit as well. And if I click on select values, these are all values related to unit. These are all systemd services that we can see their log entries. Okay, for example, I want to see the log entries of Grafana systemd service. Therefore, I type grafana-server.service and I click on run query. And as you can see here, these are all log lines and log entries related to Grafana systemd service. And we have other systemd services here as well. We can see the log entries if you want. Okay. Let's go back to VS Code. I want to show you something. Earlier, we commented out the second rule block, and here, and right now, I'm going to uncomment the second rule block here to show you something. Okay. The first parameter of the second rule block is source label, and the source label is unit. If you remember, and if you see, the first rule block, unit, was a target label. But for now, unit is our source label because in the first rule block, we actually replaced a source label with unit, and now unit actually is a source label. Okay? And I'm going to actually make changes and apply some actions on unit label. Okay? The action is keep. The default value for action is replace. If I didn't use action for the first rule block, it means that its default value was actually replaced, and I was happy with the default value. But for the second block, I want to use keep instead of replace for action parameter. Okay, and the regex is NTP the service. In some cases, you wanna, for example, keep the logs of a specific value or values for a label. Okay, for example, I want to receive the log entries of NTP service, and I don't want to receive the log entries of other services anymore. Okay. Therefore, first of all, I define the source label, and the source label is unit. And I'm going to keep the log entries of NTP.service, and I'm not going to keep the log entries of other services anymore. Okay? It means that it removes other services, and it keeps NTP.service. Actually, the parameter is regex. It means that you're able to define multiple services at the same time using the power of regex. So you're not limited to just specify a service, a single service. Okay, you can use multiple services at the same time using the power of regex if you want. Okay, I want to keep the log entries of NTP service, and I'm not going to receive the log entries of other services anymore. Therefore, I applied the second rule here. So I copy the content once again, and I go back to our terminal. I type sudo vim journal.alloy, and I replace it with the new changes. So as you can see here, we have two different roles. In the first role, actually, we replaced a source label called journal systemd unit with unit as a target label. And in the second rule block, we see that we are not going to receive the log entries of other services except NTP.service. Okay, so I save the file and I restart Alloy service and status, and everything looks good. So let's go back to Grafana. And if I refresh this query, we can see that we won't receive the log entries of Grafana service anymore. because we're just going to keep the log entries of NTP service only. Okay. So if I click on run query once again, you can see that we have no log entries in this time range. And if I go to the logs of ntp.service, and if I click on run query, I can see that we have new log entries for ntp.service. It means that Grafana Alloy was able to keep the log entries of actually ntp.service. So now let's go back to, for example, Grafana once again. If I click on run query, yeah, these are no log entries. There are no log entries in this time range. So it means that we're not going to receive, and we won't receive the log entries of other services except ntp.service anymore. Very good. This is the power of role block in Loki.relabel. Very good. It was the second scenario and the second example of collecting logs of systemd journal. So now let's dive deeper into the third example and scenario of this video. In this example, I'm going to collect and read the log entries of our Docker containers and send those log entries to Grafana Loki. Therefore, I created a file called docker.alloy, and this file contains multiple alloy components. But before talking about these components, I want to say something. If you are going to integrate Alloy with Docker, for example, to collect the logs of your Docker containers and so on, you need to join Alloy as a user to Docker group. It's important. If I go back to my terminal and if I type cat etc passwd, when you install Alloy on your Linux server, a new user will be added for you, and the name of the user is Alloy. Okay? This user must be the member of the Docker group. If you don't do that, when you configure your Docker configurations here and when you restart your Alloy service, it returns a message related to permission issues. Okay? So before configuring, you need to join Alloy as a user to Docker group. And after that, Alloy user will be able to get the list of Docker containers, to get the logs of Docker containers, and so on. So you need to type, for example, sudo user mode -ag, for example, Docker Alloy. Using this command, Alloy user will be added to Docker group. I did that already, so I don't need to use this command once again. And to verify it, I type sudo -u alloy id, and you can see that Alloy is now the member of Docker group. Okay? And after that, you can configure your file, your Alloy file here. Okay. The first component is discover the Docker. This component has two important responsibilities. The first responsibility is discovering actually the Docker engine containers, your Docker engine containers. Okay, it discovers your Docker engine containers. And then it exposes them as targets. Okay, first of all, it discovers your Docker engine containers and then exposes them as targets. And it has an important parameter related to the URL of your Docker engine, where run Docker socket. Okay? The other component, the second component, is discovery.relabel. We are going to rewrite actually a label set of Docker, and we are going to apply some actions on these targets. Therefore, this component needs an input, and the name of the parameter is targets. Okay? As I said earlier, discover.docker exposes your Docker engine containers as targets. So we need to refer to those targets. Therefore, I type discovery.docker. The name is Linux here, so I type Linux here as well. And the name of the exported field of this component. The exported field of discovered Docker is targets. So I type here, targets. I want to use the targets of the first component for the second component here. And as you can see here, we have multiple role blocks here because we're going to make some actions on these targets. Okay? Each target has actually different source labels, such as underline meta, underline Docker, underline container name, or Docker container ID, or network IP, or network mode. And if I scroll down here, I wrote an explanation for you that each target includes the following labels: container ID, container name, network mode, container label, and so on. Okay, you can use these source labels within your actually discovered label component. For example, here I have multiple rule blocks. The first one, we're going to replace meta Docker container name as a source label to replace with container name as a target label, or container ID as a target label, or container network IP and container network mode. If you're going to use other labels as well, you need to create new rule blocks within this component and add your source label and target label. Okay? There's no limitation. So this component actually needs an input, and this input is your targets. And then it applies some actions on those targets. Okay? Another component here is Loki.source.docker. This component is actually responsible to read the log entries from your Docker containers. Okay? The first parameter is host, the URL of your Docker engine, where run Docker socket, and targets and forward to. Targets means that this component is also needs some targets, because this component needs to read the log entries. So it needs to read the log entries from the targets you specify here. Discovery, that relabel, that container logs, that output. The exported field of discovery that relabel is output. Therefore, I type output here as well. And the name of the component here is container log. Therefore, I type container logs here as well. If you change it, you need to change it here as well. Okay? So we are going to read the targets from this component, discovery.relabel. Okay? Because these targets have some applied roles. And finally, we need to forward these logs to our Grafana Loki instance. Therefore, I forward it to Loki, that write, that Docker, dot receiver. This is the URL of our Loki instance. Once again, that if you're going to add other labels, you need to add role blocks here and specify your source label and target label. Okay. So I copy the content of this file, I go back to my terminal, and here I create a file called docker.alloy. So I save the file. I need to be sudoer. I save the file and I restart Alloy service. And everything looks good. So now let's go to Grafana to see what happened there. I click on Explore, the default data source is Loki, that's good, and I click on Label. Very good. The new labels have been added here: container ID, container name, container network IP, and container network mode. These are actually the target labels we configured earlier. Okay, very good. For example, if I click on one of them, like container name, its value is Minayo because I just have one Docker container up and running on my Linux server. So if I click on run query, these are all log entries related to this container. For example, if you want to see its IP, You can click on container network IP, and this is the IP related to this Docker container. Its network mode is, for example, Minayo underline default. Its ID is this. Very good. So we successfully discovered our Docker containers, and we are able to read the log entries of our Docker containers using this configuration and using Grafana Alloy. Very good. One of the amazing features of Grafana Alloy that you are able to see the flow and the graph of your Alloy configurations and the relation of your Alloy components graphical. So to see that, you need to connect to Alloy HTTP address. Okay? So the default address and the default port of Grafana Alloy is localhost 12345. So I go to the browser and I type localhost and I type 12345. Yeah, this is the interface of Grafana Alloy. And these are the components we configured earlier. If you remember, we configured 3 different Alloy configurations, Docker.alloy, journal, and local. And each of them contains multiple Alloy components. So overall, these are all components we configured earlier. Okay? And if I go to graph section here, you can see the graph and the relation of your Alloy configurations. For example, this is the graph of local configuration. This is the graph of Docker configuration. This is the graph of systemd journal configuration. Okay. And also, you can see the relation of your components as well. Okay, we have 3 different graphs because we configured 3 different Alloy configurations. Okay, local, Docker, and systemd journal. And if you click on each of these components, you can see their details as well and the configuration we applied on them. Okay, very good. It's very, very good. As you know, the default address and the default port of Grafana Alloy is localhost 12345, but you're able to override the address and the port. Okay, so to do that, you need to go to etc default alloy. If you remember from the previous section, we overrided the default config path of Grafana Alloy using config underline file environment variable. But now I'm going to change the content of custom args environment variable. I'm going to add actually an argument to this environment variable to override the default address and the default port of Grafana Alloy. So to do that, I type --server.http listen-address addr equals to, for example, I'm going to change localhost to all IPs. So I type it here. And I want to override the default port from 12345 to 12346, for example. Okay? So I save the file and I restart Alloy and I get a status of Alloy and everything looks good. I go back to my browser and if I refresh this page, I need to change the port because I changed it earlier, 12346 instead of 5. And yeah, this is the interface of Grafana Alloy. So we successfully overridden the default address and the default port of Grafana Alloy. It was actually an additional argument for Grafana Alloy that we passed through custom args environment variable. If you want to see all valid additional arguments of Grafana Alloy, you need to go to Alloy documentation here, click on reference, click on command line interface, and click on run. And here, if I scroll down, these are all valid, actually, additional arguments you can pass through custom args environment. Okay? Very good. It was about connecting to Grafana Alloy through its HTTP listen address. So now we are going to deploy and install Grafana Alloy on Kubernetes. Okay, our scenario is collecting logs of our pods. Okay, therefore we need to deploy Alloy on Kubernetes to collect those types of logs and sends their logs to Grafana Loki. Okay. So let's go to the Alloy documentation here. I go to setup and install. I choose Kubernetes here, and the title is deploy Grafana Alloy and Kubernetes. First of all, you need to install Helm on your computer, on your server. And then the first step is adding the Grafana Helm chart repository using Helm repo at Grafana. Then you need to update your Grafana Helm chart repository, Helm repo update, and then create a separate namespace for Grafana Alloy. If I go to my terminal and if I type Helm repo list, you can see that I already added Grafana as a Helm chart repository. And if I type kubectl getns, I have a namespace called alloy-logs, and I want to use this namespace to deploy and install Alloy on. Okay? And the last command is this, helm install, installing Alloy on Kubernetes. Very easy to install Alloy, okay? But actually, most of the time, you need to override some values of Alloy Helm chart to customize it based on your needs and based on your use case, okay? So to do that, I click on Configure Alloy. And in this page, we have a title called Configure the Helm chart. It has a link to values.yaml. I open it. And these are actually all key value pairs related to Grafana Alloy Helm chart. Okay, and we need to override some of them based on our needs. I copy this content, I go to my VS Code, and I create a new file here called original values.yaml. And also, I create another file called values.yaml for actually overriding some different values of Grafana Alloy Helm chart. Very good. One of the most important option and parameters of this Helm chart and Helm values actually is controller type. Grafana Alloy has different deployment modes. It means that you can install Alloy as daemon set, as deployment, or as stateful set. The default value is daemon set. Okay? First of all, you need to specify which one is better for you based on your use case. Okay? To answer this question, you need to go to Alloy documentation, and here click on Setup and Deploy. Okay? In this page, it explains different modes of Grafana Alloy, and finally, you will realize which one is better for you. Okay? The first one is a stateful set. And it says that deploying Alloy as a stateful set is the recommended option for Prometheus metrics collection, where you have write-ahead log directories and persistent storage is important for you. Okay? In this case, the stateful set is better. Another option is Kubernetes deployment. We can use this type in cases where persistent storage is not required, is not important for you, such as a traces-only pipeline. For example, if you want to collect your traces from different sources, such as OpenTelemetry, and sends traces to providers such as Tempo, and you have a traces-only pipeline, you can use Alloy as a deployment. Okay? And if I scroll down here, another option and another type is daemon set. It's required for node level observability, for example, cAdvisor metrics, and collecting pod logs. As you know, in this example, in this scenario, and in this video, I'm going to collect the logs of our pods. Therefore, I realized that daemon set is better for me based on the use case I have, collecting pod logs. Okay, so I'm happy with the default value. I don't need to change it. Daemon set is better for me based on my use case. Okay. Another option is mounts. And its option is val log equals to false. If you change it to true, it mounts val log from the host into the container for log collection. Okay, so I prefer to use it. Sorry. I go to values.yaml and I type alloy. And here, mounts val log equals to true. Okay, it's good. Another important option is config map. If you remember from the previous sections, we created different alloy configuration files like docker.alloy, journal.alloy, and local.alloy. Okay, these are actually our alloy configurations. Okay, when you want to use alloy and Kubernetes, you need to put your alloy configuration into a Kubernetes config map. Okay, therefore, Grafana Alloy Helm chart by default creates a new config map for you because create here is true. And also, you can assign a content to the new config map using this parameter here. This is the first option. Another option is changing this parameter from true to false because in some cases, you have a config map already and you don't want Alloy to create a new one for you. In this example, I have a file here called kubernetes-podlogs.yaml. This is actually the config map I want to use. This is the Alloy configuration, which is responsible to collect the logs of our pods. Okay, so I want to use this config map and I don't want Alloy to create a new one for me. Therefore, I prefer to change create from true to false. So I copy these two lines, I go to values.yaml, and I change it to false. The name of the config map I want to use, and the name of the key of the config map. So if I go back to our config map, the name of the config map is alloy-config. Very good. And the name of the key in this config map is config.alloy here. As you know, Kubernetes config maps has a key value pair structure. Okay, the name of the key here is config.alloy, and the value is actually the alloy configuration. Okay, so the name of the key is config.alloy. In this example, Grafana Alloy doesn't create actually a config map for me. Okay, very good. So I want to use these values and I want to override the default values of Grafana Helm chart using this file. Very good. So let's go back to our terminal, and here I have a directory called Alloy, and there are two different files in this directory, values.yaml. If I open it, these are the values I want to override, val like true, and the name of the config map I want to use. And also, this is the config map I want to use, okay? I'm going to explain this config map in a few minutes, so don't worry about it. But first of all, let me to install Alloy and Kubernetes to see how it works, and then I will get back here soon to explain this config map, okay? So, first of all, I type kubectl apply-f config map.yaml-n alloy-logs. And if I type kubectl get config map-n alloy-logs, the config map has been created. And now we are going to install and deploy Alloy on Kubernetes. I type helm install alloy-logs. The name of the repo is grafana/alloy. The namespace is alloy-logs and values.yaml. This is the file I want to use to override some values of Alloy Helm chart. Okay? I enter. And very good. Grafana Alloy has been deployed on my Kubernetes cluster. So if I type kubectl get pod-n alloy logs, Alloy is now up and running. Very good. The most important thing you need to remember that you're able to install and deploy Alloy on different namespaces for different use cases. For example, in some cases, you want to collect the logs, metrics, and traces at the same time. In this situation, you can install and deploy different types of Alloy instances. For example, an Alloy instance for collecting logs, an Alloy instance for collecting metrics and traces in different namespaces with different values. And those Alloy instances are able to use their own values, actually. Their own config map, their own actually types, and so on. Okay? So you can install and deploy Alloy instances in different namespaces for different use cases if you want. So if I type kubectl get polish in Alloy logs once again, you can see that it's now up and running. Very good. We successfully deployed Alloy on our Kubernetes cluster. So it's time to explain this config map. Okay? The first component I'm using here is discover.kubernetes. Okay? This component actually is responsible to discover targets from Kubernetes resources. The important parameter here is role. The role is pod. Okay? It means that I'm going to scrape targets from Kubernetes pods. Okay? The role can be pod or service or node or ingress or endpoint. Okay? If you want to see the list of valid roles you can use, you can go to Alloy documentation, scroll down, click on reference, components. I scroll down, discovery, and then click on discovery.kubernetes. Okay. First of all, it explains that what is the responsibility of discovery.kubernetes. It allows you to find script targets from Kubernetes resources, and you're able to use different role. For example, you can use node role or service role or pod role or endpoint role, endpoint slice role, ingress role. Okay. It depends on you. For example, in this scenario, I'm using pod role, and the pod role discovers all pods and exposes their containers as targets. Okay. And if you see here, you realize that each role has its own labels here. Each role has its own labels. Okay. So you can use these labels in discovery.relabel component, for example. If you remember from Docker section, we use discovery.relabel component to replace some different source labels with target labels. I'm going to do the same here as well. Okay. Therefore, the second component is discovery.relabel, and I'm going to actually replace labels of pod role to new labels as target labels, actually. For example, I'm going to replace meta Kubernetes namespace source label to namespace label, or pod name to pod, or container name to container, and so on. Okay, I'm applying different rules to actually the labels of pod role. Okay, very good. The third component here is local.file match, and it has an important parameter called path underline targets, and you need to specify targets for this component. Therefore, actually, I link the exported field of discovery.relabel component to this component, actually. Therefore, the value of path underline targets will be discovery.relabel. If you see here, the name is pod underline logs, so I type pod underline logs here as well. And the name of the exported field of discovery.relabel here is output. So it's required to type output here because this is the name of the exported field of discovery.relabel. Okay. The next component is Loki.source.file. This component actually is responsible to read log entries from the targets you specify. Okay. It read log entries from these targets actually. Local here dot file match dot pod underline logs dot targets. The name of the exported field of local.filematch is targets. So I type targets here. So please pay attention that what is the name of the exported field of each alloy component. It's so important. Okay? You must know that what is the name of the exported field of each alloy component. Okay? So this component actually reads the log entries from the targets you specify here and then forwards those log lines to any other Loki components. For example, here it forwards those log lines to Loki.process.pod underline logs dot receiver. Okay? Actually, this component. Okay? Loki.process is a component which responsible to process your log lines. For example, you want to add one label or more than one labels to a set of log lines. You want to drop a label from a set of log lines and so on. Okay, you can do things like this using Loki.process. And in this example, we are going to set new labels for a set of log lines. If you see here, this component contains two different stage.match blocks. You're able to create new stage.match blocks for this component if you want. But for now, it contains two different stage.match blocks, and each of them has its own parameters, actually. Okay? The first stage.match is responsible to set two new labels for a set of log lines, flags and stream. Okay, so let's dive deeper into the first one. The first option is selector. The selector is important because it selects and filters those log lines which include a specific label here. For example, this is a label actually. Label is a key value pair. The key is TLP container runtime and the value is container D. So it selects and filter those log lines which includes this label. TMP container runtime equals to container D. Okay? And then it uses stage.cri here. This command, this line actually enables a predefined pipeline to read log lines using the CRI logging format. Okay? If the TMP container runtime is container D, you can use stage.cri here to enable a predefined pipeline to read log lines using the CRI logging format. And then finally, I'm going to add two new labels to the log lines includes this specific label. So I type stage.labels and then I type flags and stream. These new labels will be added to the log lines includes this specific label. Flags and a stream. Okay. The key will be flags and the key will be a string, two different keys, and their values will be extracted based on flags label, based on stream label. Okay, very good. The second stage.match actually selects and filter those log lines which includes TMP container runtime equals to Docker instead of container D. And then it enables a predefined pipeline to read log lines using actually the Docker log format. Okay, stage.docker instead of a stage.cri. And here I'm going to add a new label called stream. The key will be a stream and the value is based on the extracted value of stream. Okay. And finally, I'm using another stage here, stage.label underline drop. As I said earlier, you are able to, for example, add a new label or drop a label if you want in Loki.process component. So now I'm going to drop this label TMP container runtime from all log lines include this actually label. Okay. And finally, you need to forward these log lines to uh, any other Loki component, and other component here is Loki.write. And in this component, we're going to write those log lines to Grafana Loki, and this is actually the address, the service address of Grafana Loki on our Kubernetes cluster. Loki-gateway.loki.svc.cluster.local. Okay, this is the actually the service of Grafana Loki on our Kubernetes cluster. Okay, very good. So we applied this config map when we installed Grafana Alloy. So if we go to Grafana here, and if I click on Explore, you can see these labels here. Container, file name, flags, job, namespace, pod, service name, and stream here. Okay. If you remember, we added stream and flags here. If you remember from here, we added two different labels, flags and stream, and also here. Okay. And also in discovery.relabel component, we replaced some different source labels with new target labels, such as namespace, pod, container, job, and so on. Okay. And you can see all of them here. Okay. Very good. One of the most important things you need to remember that whenever you, for example, change your config map, change the content of your config map, actually, Grafana Alloy is able to automatically reload your configuration. Okay? Because if you get back to the default values of Grafana Alloy Helm chart, and if I search for reload, you can see that Grafana Alloy has a component called config reloader. Okay, and it's enabled by default. Okay, it automatically reload Alloy when you change your Alloy configurations. So whenever I make a change to my config map, for example, Grafana Alloy understands and then reload your Alloy service actually. Okay, so one of the labels here is namespace, and the values are Alloy logs, Grafana, Cube system, Loki, and so on. If I click on Alloy logs, and if I click on run query, these are all log lines related to actually the log lines in namespace, Grafana Alloy namespace actually. And if you click on one of them, you can see a set of key value pairs, a set of labels here. Stream, which we added, and flags, which we added earlier using stage.match, and look at the process component actually, and other labels here. Very good. There is also a very simple application in my Kubernetes cluster that I deployed earlier, and I want to make multiple requests to this application to make new logs. Okay, therefore, if I type kubectl get pod -n my app, this is the pod related to my application. And if I go back to the browser and I type app.local, this is the interface of my application, okay? And it returns a very simple message, collect logs with Grafana Alloy. And I make multiple requests to this application. Very good. So if I click on namespace here, a new value has been added. My app is a new value here. And I click on run query. And these are all log lines related to actually our application. And if I click on one of them here, These are the key value pairs, and these are the labels of our application. Okay. In this time and in this scenario, I want to add a new label to these log lines, to the log lines of my application. And for example, I want to add HTTP method as a new label here because I want to check the HTTP method of each log line. Okay. And I want to do that through Loki.process component and a new stage.match block. Therefore, I copy one of these stage.match blocks from here and I paste it here as well. So I'm going to make some actions on the log lines of my application. Therefore, I need to select those log lines. As you can see here, one of these labels is namespace my app. Okay, I want to filter and select all log lines which includes this specific label. So I go back here and I change the selector from TMP container runtime to namespace, and the value will be my app. I want you to know that you're able to use regex as well if you want. For example, in some cases, you want to actually select multiple labels at the same time. In this situation, regex comes into the play to help you. For example, you can change it to something like this, and you can change my app to like namespace, my app, or your app, actually. For example, the namespace can be my app or your app using regex, but I'm happy with my app here. Okay, very good. But I said that you're able to use regex if you want. Okay, first of all, we define that we're going to make some actions on those log lines which includes this specific label. We don't need to use stage.cri, but instead, we are going to use stage.regex here. Okay, it has an important parameter called expression, and it has a specific syntax, special syntax, actually. Here, we have to define the name of the label we're going to add. The name of the label I'm going to add is method. So I type method here. And after that, we have to specify the regex we want to use because we have to extract the HTTP method from our log line. Okay. For example, in this log line, the HTTP method is get. It can be get or put, post, delete, and so on. Okay. So we need a regex to extract the HTTP method from each log line. Therefore, we have to specify the regex here. For example, the value will be get or put or post or delete. Okay, so the name of the label will be method. The method is the key actually, and the value will be the result of this regex. Okay, it's important. In the stage of labels, we just need a single label, so I remove the second one. And as I said earlier, the name of the label is method, so I change flags with method here, and everything looks good. So I copy this content, I go back to my terminal here, I open config map, and I'm gonna use the new content here, okay? As I said earlier, Grafana Alloy has a component called config reloader, and it reloads Alloy when it detects a new change within your Alloy configuration. Okay, so I save the file and I need to apply this config map once again. So let's go back to Grafana Alloy. I go to alloy-logs namespace to see the new logs of Grafana Alloy namespace. And I'm going to wait for a new message like this, successfully triggered reload, to find out that Grafana Alloy reloaded its new configuration. So I'm waiting for that. And yeah, config reloaded. Okay, so let's go back to explore once again, and I want to make multiple requests to my application. Go back to here. I click on namespace, my app, and I click on run query here. If I scroll down and if I click on one of these log lines, you can see that a new label has been added here successfully. The name of the label is method and its value is get. So we successfully added a new label to a set of log lines using a looky.process component and a new stage.match block. Very good. So thank you very much. I think we covered all required topics related to this video. We found out how to collect logs from local files, systemd journal, Docker containers, and Kubernetes pods. And it was very useful, I think. And in the next section, we're going to dive deeper into collecting metrics with Grafana Alloy. Hope you like it, and see you soon.